in Mexico City. And high levels of air pollution have been causally linked to negative impacts in health, labor supply, productivity, educational outcomes, among others. And in the longer term, governments can implement policies and programs to reduce air pollution. But what we focus on in this paper is, in the short term, whether air quality alerts can increase avoidance behavior on high pollution days, reducing exposure. With this in mind, we designed a randomized controlled trial in Mexico City to determine households' willingness to pay for real-time SMS air quality alerts, and also to study the impact of SMS air quality alerts, monthly SMS air quality reminders, and the provision of a reusable N95 mask on households' pollution information and avoidance behavior. So we hypothesized that individuals may face two key barriers to engaging in effective avoidance behavior. The first one is that they may lack real-time information on which days have high air pollution. And second, they may lack protective technologies or goods that allow them to engage in avoidance behavior. So we designed this study to be able to address both of these barriers. There's three main takeaways that I'd like to highlight. First, pollution perceptions matter much more for willingness to pay than actual air pollution. Second, the SMS alerts increase the salience of air pollution. And third, the SMS alerts and the masks are unlikely to substantially decrease exposure, even though they do increase the salience of air pollution. So I'll show empirical evidence that leads to these three main takeaways. Our paper contributes to the literature on the value of air pollution information and the effects of air pollution information on avoidance behavior. So there's a pretty large literature studying air quality alerts disseminated through the media and through websites and smartphone applications. There's very little evidence coming from developing countries. Related to this literature, we can make three contributions. So first, we study passive SMS alerts that are delivered directly to participants' phones. This means that we take out any concerns of limited attention that's required when air pollution or when participants need to actively seek out air quality information daily on their own. Second, we provide empirical evidence for a large city in a developing country that has a long and well-publicized history of high air pollution. And third, because all of the prior literature looked at air quality information provided broadly, generally to the population for free, we're able to provide a fine incentive-compatible measure of willingness to pay for real-time actionable air quality information, and we can document the correlates of willingness to pay. Importantly, together, our results extend this literature in a novel direction by providing empirical evidence of the strength of perceptions in air pollution information and avoidance behavior. So we use a novel application or tweak of the Becker-DeGroot-Marchak method to elicit an incentive-compatible measure of willingness to pay for the air quality alert service. We are also able to unconditionally randomize participants into 4 cross-cutting treatment groups, including the alert service. So this experimental design allows us to do 4 main things. First, we can recover the demand curve for the alert service. We can study the correlates of willingness to pay for the alert service. We can estimate the treatment effects of the mask and higher compensation on willingness to pay. And finally, we can estimate the causal impact of the alert service on pollution information and avoidance behaviors in the follow-up survey. So our 4 cross-cutting treatment arms are a 1-year subscription to air pollution alerts delivered by SMS, a free reusable N95 mask, a 1-year subscription to monthly SMS reminders, and 50% higher compensation for completing the baseline survey. So I'll just give a little bit more detail about each of these treatment arms. So households in the alert treatment group received an SMS message at 7 a.m. on days in which PM 2.5 or PM 10 was abnormally high near their house and their neighborhood, and also on days in which the Emeka, which proxies ozone in most cases, was forecast to be high. The message also contained information on whether or not the filter mask, the N95 mask, would be an effective form of protection against that pollutant. The reminders treatment group consisted of a monthly SMS reminder sent on the first day of the month that contained information about seasonal air quality trends and avoidance behaviors. Households assigned to the mask treatment received a free reusable N95 mask, and households assigned to the higher compensation treatment received 150 pesos as compensation for completing the baseline survey, relative to control households, which received 100 pesos. Overall, 50% of our participants are assigned to each of the alerts, mask, and reminders treatments, and 30% are assigned to the compensation treatment. So this means that about 9% of participants are in our pure control group. We also provided all households with information about air quality as part of the baseline survey prior to eliciting willingness to pay. So we provided information on air quality trends, risk of negative health impacts, and effective avoidance behaviors. So during our baseline survey, we first reveal participants' compensation and whether or not they will receive a free N95 mask. Then we elicit willingness to pay for the alert service. And finally, we reveal whether or not the participant will receive the SMS alert service and the reminder service. So this is how we're allowed to, this is how we're able to estimate the treatment effects. This slide shows the progression of the baseline survey and the experimental timeline. So we conducted our baseline survey between June 18th and August 1st in 2019. We conducted, so the SMS reminders and the alerts services run for 1 year. So they continued until July 31st, 2020. And we conducted our follow-up surveys between November 23rd and December 24th. We conducted 2 rounds of follow-up surveys, which was the same survey conducted approximately 2 weeks apart. The figure below shows the progression of the baseline survey. So first we collect pre-treatment questions, such as demographic information. We also provide the information about air quality. Next, we inform households of their mask treatment and 150 peso treatments. Then we elicit willingness to pay for the alerts using the BDM mechanism. And finally, we randomize households into the alerts or the reminders treatments. So first, I'll discuss the willingness to pay results. In the pure control group, 72% of respondents had a positive willingness to pay. 11% of respondents reported willingness to pay of 0. This means that they would accept the service if it were offered to them for free. And finally, 17% of households had a negative willingness to pay, meaning that they indicated they would refuse the service even if it were offered for free. This figure shows the inverse demand for SMS air quality alerts. The horizontal axis shows the share of the sample with willingness to pay above each price, and the price in pesos is shown on the vertical axis. So for reference, the marginal cost for a median user in our sample is approximately 125 pesos, and this is shown in that horizontal line. Our first set of results looks at the correlates or predictors of willingness to pay. The first column of this table shows all of the covariates, and the second column uses lasso double selection to select the included predictors. So first, we find that male, younger, and higher income respondents are willing to pay more for the SMS service. So this implies that willingness to pay for air quality alerts may increase over time with economic growth and as younger cohorts comprise a larger share of the population. We also find that reporting that there is a high pollution in recent days is correlated with willingness to pay. But interestingly, actually experiencing a high pollution day prior to the survey is uncorrelated with willingness to pay. So there's no households in our sample that experienced a high particulate matter day prior to the survey, given the time of year that we conducted the baseline, but 56% of our sample experienced a high ozone day prior to the survey. Since respondents' perceptions of recent pollution levels are highly correlated with willingness to pay, but actual pollution levels are not, this implies that we can rule out that the effect is coming through short-term health impacts of high air pollution. Next, we estimate the treatment effects of the free N95 mask and higher compensation on willingness to pay for the alert service. The first column shows the two treatment effects, and the third column includes the interaction between the two treatments. So you can see that first, higher compensation increases willingness to pay for the alert service, indicating either a cash on hand liquidity constraint or possibly anchoring around the amount of compensation. Second, we don't find any statistically significant positive effect of the mask, although the treatment effect is positive. This shows that mass and the value of real-time information here aren't clear complements. If it was a positive statistical significant effect, it would indicate that the value of information is higher when you have an effective form of avoidance behavior available to you. So one possible explanation for this is that households effectively rely on rules of thumb or routines to decide when to engage in avoidance behavior, as opposed to trying to target that behavior to specific days. And this is consistent with what we find in our follow-up survey results. So next, we show the effects of the treatment effects of each treatment on household air quality information and avoidance behavior using information from the follow-up surveys. So this table shows the effects for information on air quality. So I'll focus on the alerts treatment. We observe a large statistically significant effect of the alerts treatment on reporting having learned about air quality from an SMS alert, and a substitution away from learning about air quality through TV. We find that the alerts increases reports that there was a high pollution day in the past week. In the fourth column, this effect is about 10 percentage points relative to a mean of 38% in the control group. The last two columns show that the alerts treatment does not increase the accuracy of households' identification of high pollution days. The fifth column shows the percent of days from the past week for which the respondent correctly identifies whether or not there's high pollution. And we see no effect on this outcome. So this could imply that households in the alert service generally recall receiving an alert, but they have difficulty remembering exactly which day, so inaccurate recall. Or it could be that the alerts raise the salience of air pollution without a meaningful impact on precise air pollution information. So to test which one of these seems to be driving our result, in the sixth column, we restrict our attention to only the day of the survey and the prior day. And we still see that households in the alert treatment are no more accurate at identifying high pollution days. So this in general indicates that alerts increase the salience of air pollution, but they do not increase the accuracy of air pollution information. This table shows the treatment effects on avoidance behavior in the Endline survey. The first four columns show the effects of reporting engaging in different types of avoidance behavior on the last perceived high pollution day. So the alerts treatment increases the likelihood that households report doing something different on the last day that they perceived high pollution, and also increases the likelihood specifically of staying inside with windows closed. The last two columns show that households that received a free N95 mask are more likely to report using it in the prior 2 weeks in column 5, but are not more likely to report using it on the the specific days that had high pollution, and that's in the last column. So overall, our results show that households in the alerts treatment and in the mass treatment are engaging in more avoidance behavior, but that is not targeted to the high pollution days. So it's unlikely to significantly reduce air pollution exposure because this avoidance behavior doesn't occur on high pollution days. So to conclude, our results suggest that although alerts increase the salience of air pollution alerts aren't conveying as much or as precise information as intended. Together, our results illustrate the power of perceptions. The perception of high pollution days matters more for willingness to pay for air quality alerts and also for avoidance behavior than actual high pollution days. And in cities with long histories of high air pollution, policies that rely exclusively on information provided through information communication technologies may not be effective. While information can be provided at low cost, we might need more paternalistic policies to actually reduce the population's exposure to air pollution. Thank you so much.
Okay, thanks, Bridget. It was great. And you left us with a few minutes to discuss. So if anyone wants to jump in, we have like around 10, 12 minutes to ask questions or to discuss anything related to the paper. So feel free to just jump in. Yeah, Natalie. Hi, Natalie.
Hi, Juan Pablo. Thank you, Bridget, nice presentation. I have two questions / comments. One is that you showed the results that I think it was air pollution was more salient among men. I wonder if this is because, in a developing country, it's more likely that men will go out and work. This may relate to Juan Pablo's presentation in the next minutes, but is that the intuition there, that because men are likely more exposed to outdoor pollution, therefore pollution will be more salient to them? And if so, do they have chances to, engage in avoidance behavior? And the second question, that is probably more a clarification question. I saw that the follow-up survey period covered the pandemic. So I wonder if you guys observe any change in the perception towards the use of the N95 mask, and whether you guys are controlling for that. Thank you.
Hi, Natalie. So both are really good questions. So we don't randomize whether or not the respondent for the household is male or female. Whoever is there is there. So I can't really say too much specifically about what the gender means. It's all correlations. I think we can look a little bit at whether men are more likely to work outside the house, and maybe that could be driving it. I'm also suspicious that that men earn more income and that's driving this effect. And I don't think we can look at that directly because we have household income. We don't have respondent income themselves. So I think it could be either of those. And then regarding the pandemic, well, yeah, that definitely was a problem. So our baseline survey was conducted in the summer of 2019, and we expected to do a follow-up survey in the summer of 2020. And so we did, what was our follow-up survey in this case that I showed in the presentation was conducted in November and December 2019. So it was prior to the pandemic. And we had planned that would be the midline survey and that we would conduct a follow-up survey, an endline survey at the end of the SMS and treatment and reminders treatment period. But we ended up scrapping the endline survey for exactly the reasons that you mentioned, that the N95 mask all of a sudden becomes much more valuable. We also had some plans to elicit willingness to pay for the mask after having received information for a year and learning about air pollution. And we couldn't buy N95 masks to do that at the end line. Practically or morally, we couldn't be buying them and handing them out since they're supposed to be conserved for healthcare workers at that time. So we ended up having to scrap the end line survey because of the pandemic. But I think that because we have this midline survey before, which is before Christmas 2019, I think that everything that we have is prior to anyone's concerns about global public health pandemic.
Thank you. I also wonder, it would be interesting to look, at the sort of perception of the use of the mask after the pandemic, right? I'm thinking, maybe before people didn't want to use it because you would be ashamed. It's not common, right? Or in Latin America, I guess it wasn't common. But maybe not anymore, right?
Yeah, I totally agree with you. Yeah.
Thanks, Bridget and Natalie. Any other question? We have a couple more minutes. Okay, everyone seems quiet. I have a question. No, so I was wondering, and it's linked to Natalie's comment as well. So maybe if you can say a bit more about the subject of this intervention, and because as I will present later, we have very heterogeneous responses to pollution, and some of these may seem like they contradict your own results in your other paper, but what I'm wondering is whether the variation across informality or level of income or level of education is as significant here as the one that we exploit in our paper, where we look at a national, a city representative survey. So I was a bit curious about basically your sample composition and the group you're targeting with this intervention.
Yeah, so that's a good question. Our sample is definitely not representative of Mexico City as a whole. We're focused on kind of a upper lower class income level. I don't know what percentage are informal workers. We don't have that information. But we targeted, like, our sample selection was specifically done to select relatively lower income areas and but that were relatively safe. So this was from both the standpoint of, actually finding people to survey and having relative consistency across the different neighborhoods that we go to, and also practically for surveyor safety. So we selected a specific kind of sample of neighborhoods that we would go to. So we don't have, in our sample, we don't really have anyone who's extremely high income, and at the same time, probably not anyone who's at the very bottom of the distribution.
Okay, thank you. I think that may put those set of results together nicely. So it's good to keep in mind. Any other questions? So if there's no more questions, we can move to Juliana's presentation on temperature and morbidity in Colombia, and then we'll have more time at the end to discuss, if you want. Okay.
Okay, so can you see my screen?
Yeah, perfect.
Okay, so thanks everyone for being here. I'm gonna deviate a little bit about pollution, but still the impacts of temperature and health outcomes. So this is a work in progress, so all of your comments are appreciated. I'm gonna talk to you today about temperature and the morbidity in Colombia, but I will start giving you more details now. So the changing climate has spurred an interest in quantifying the economic damages associated to this environmental risk. And these economic damages often include, but are not limited to, losses in agricultural productivity, losses in productivity, in biodiversity, and health. And out of the health and health outcomes in general tend to be important because health is not only valuable on itself, but health has a productive side. And in particular, out of the health outcomes, mortality has received much of the attention. In fact, there's a huge literature trying to quantify the costs of climate change in terms of mortality, based on the empirically founded estimates on the relationship between short-term variations in temperature and mortality. And what do we know about this relationship? We know that instances of extreme heat and extreme cold increase mortality with close to zero effects at mild temperatures, giving rise to what the literature has called as the U-shaped relationship between temperature and mortality. However, much less is known about the effect of these temperature variations and temperature shocks on health outcomes that not necessarily result in death, that is in morbidity. Death is an extreme outcome, but we know that we might have temperature shocks that are affecting health that not necessarily result in death. And ignoring these morbidity outcomes might lead us to underestimate the cost of climate change and miss the direct burden that climate change might impose on health systems. But moreover, understanding this temperature morbidity relationship is important because it might shed light on adaptation opportunities. And in fact, access to healthcare and good quality healthcare can serve as a mediating factor between this temperature, between the relationship between temperature and mortality. So what do we know about the effect of temperature on morbidity outcome? Though the literature is thin, we know a little bit. So we know that emergency room visits and hospitalizations increase after the exposure of extreme heat and extreme cold. In fact, what drives this relationship has been documented to be external factors, cardiovascular illness, and diabetes. And also we know that fetal exposure to extreme heat affect health outcomes at birth. But when you look closely to the literature, you see that most of the evidence comes from developed countries, usually located in the temperate region. That is a few states in the US, some European countries, a handful of cities in Europe also. But you see that we are clearly missing some countries very specific located in tropical areas. And there are reasons to suspect that health responses in countries located in tropical areas might differ from the health responses that we observed in the temperate region. And there are two reasons to believe this. The first one is that on average, this region tends to host developing countries and lower income countries that tend to have weaker health systems. And on the other hand, there are environmental difference and key environmental difference that might give rise to different responses in health. So I'm gonna give you two examples. The first one is that populations in the tropics are exposed to narrower ranges of temperature throughout the year, given their closeness to the equator. So many of you know, but for someone like me who's located in Bogotá, average temperature throughout the year is around 60 degrees Fahrenheit. No extreme heat or extreme cold days are observed throughout the year, precisely because of the lack of seasonality due to the closeness to the equator. And so if we were to extend the estimates from the temperate region to a place like Bogotá, we would be observing close to zero effects from changes in temperature. On the other hand, the relevant causes of death and morbidity in temperate areas might differ a little bit from those in tropical areas. So for example, in tropical areas, infectious diseases have been documented to react to changes in temperature. And so infectious diseases in a tropical country tend to be very prevalent, unlike places in the temperate region, precisely because of the lack of winter temperatures that usually kill these infectious diseases. So in this paper, what I do is that I explore the response of health services usage to changes in temperature using information from Colombia. So I use the universe of services provided by the health system, that is administrative data in Colombia, combined with fine scale weather data. And I show that hospitalization rates increase monotonically in temperature, even in the narrow temperature range that I observe in a place like Colombia. And I will get into more details about that in a second. I find that hospitalizations due to infectious diseases and maternal or pregnancy-related care mainly explain the results. And comparing to the literature, these are novel findings in the sense that effects have been found at very extreme temperatures, and I'm finding them here at moderate temperatures. And the mechanisms that give rise to the health temperature relationship in temperate regions tend to be a little bit different than what I'm finding here, which is primarily due to infectious diseases and maternal and pregnancy related care. So now let me tell you a little bit more about the data sources that I use. So for temperature data, I'm using reanalysis data from ERA Interim. This is a reanalysis product that combines observational data and forecast models at a very fine grid level resolution. With this product, I have 4 readings of temperature throughout the day, which I get the average at the municipality level. So I aggregate at the municipality level and construct a discrete version of the annual distribution of temperature. So municipalities, for those of you who don't know, are the smallest administrative units in Colombia, and I have approximately 1,100 of those. So this annual distribution of daily temperature is going to be my main explanatory variable in my empirical specification, and this is how I construct it. I classify temperature in 7 different categories. Here I'm plotting the average temperature, the average annual temperature distribution for Colombia. Each bar is representing the number of days per year that the average person experiences in the temperature category. So if you're familiar with this literature, you see that I'm using much narrower temperature bins. So I'm using 2 degrees Celsius bins in comparison to 10 degrees Celsius bins in temperate places. And I need to do this because if you see that the temperature range in Colombia goes from less than 17 Celsius to more than 27 Celsius. And so if I don't split it into very fine bins, I wouldn't have enough variation. So as I mentioned before, I'm using this in my empirical specification, and I'm doing this to capture any nonlinearities of the temperature morbidity relationship, pretty much a la Deschênes and Greenstone 2011. In terms of the morbidity data, I'm using the universe of health services from the CISPRO system, which is compiled by the Ministry of Health and Social Protection, and I have this information from 2009 to 2016. In particular, I have information for 4 outcomes: consultations, procedures, hospitalizations, and emergency room visits. And in the interest of time in this presentation, I'm going to show you results only for hospitalization rates. Each type of service I can classify by diagnosis according to the classification of diseases by the World Health Organization. And again, I can aggregate at the year municipality level and by counting the total number of cases, and with this and population information from the National Statistical Agency in Colombia, I calculate the morbidity rate that I'm using. With this, I have a panel of approximately 8,000 observations. So now that I described my main variables of interest, I will introduce my empirical strategy. So here I have a morbidity rate. In this particular presentation is going to be hospitalization rate per 100,000 inhabitants at the municipality I and year Y level. My main variables of interest are this bin temperature, which is the annual distribution of temperature that I showed you a couple of slides ago. I have seven of those variables. I need to exclude one because since days add up to a constant in the year, I need to exclude one. My reference category is going to be temperature bin 23 to 25 degrees Celsius. And my parameters of interest are going to be these beta J's, which you interpret in the following way. One additional day in temperature bin J is going to change annual morbidity rate by beta J per 100,000 inhabitants relative to the impact of a day in the reference category, which is the 23 to 25 degrees Celsius. In each specification, I'm controlling for precipitation only. I also construct an annual distribution of precipitation. I'm including municipality fixed effects. I'm including department year fixed effects to capture any any trends in mortality, in morbidity that are common across departments. Departments are fairly the same as states in the US. And I'm also including linear municipality trends. My standard errors are gonna be clustered at the municipality level. So my main finding is that hospitalization rates increases in temperature. So here in this graph, I'm plotting the beta J coefficients that I showed you in the empirical specification. Each dot corresponds to one beta J. In the x-axis, I have each temperature bin, and on the y-axis, I have the betas changing the hospitalization per 100,000. So you see that for every temperature bin, this relationship is increasing in temperature. So for example, here, if you see the coefficient associated to the temperature category above 27, I see that exchanging a day in the reference bin of 23 to 25 for an additional day in reference bin 27 increases hospitalizations by 29.6 per 100,000, which is approximately 0.86% of the annual hospitalization rates. So these results are robust to different specification, including different fixed effects, but most importantly, they are robust to including humidity controls. So if you look in column 4, in column 4, I'm using my baseline specification, but I'm including humidity controls. As of now, I am using specific humidity from the product ERA 5. I have daily specific humidity. I construct a distribution very similar to that of the temperature distribution. I have a baseline category, which I am excluding. And I'm showing that when I include these controls, the point estimates for temperature remains almost unchanged. The magnitudes are very similar, the signs are the same. However, there's an interesting finding, which is that that hospitalization rates are also increasing in humidity. So this gives me a little bit of safeguarding in the sense that my temperature coefficients are not confounded by humidity, by the humidity variables. However, I'm exploring this hypothesis further, and as of now, I am processing relative humidity data to construct a measure of wet bulb temperature, which is a measure that accounts for the interaction between the two. And so that would be my next step, but I'm processing the data now. But as of now, with the information on humidity that I have, I'm controlling for that, and I'm still finding an increasing relationship between temperature and hospitalization rates. So in trying to explore the mechanisms that give rise to this relationship, I estimate my empirical specification by diagnosis. I can classify each hospitalization by 21 different diagnoses. Here in the graph, it's a very similar graph to the one that I showed you one slide ago, but I'm plotting the morbidity temperature response function by diagnosis and highlighting only those that are relevant and statistically significant. At this point, I'm not showing sorry, the English translation, confidence intervals. I'm sorry, I'm not showing confidence intervals for the sake of clarity in my graph. So if you see, the biggest effects, absolute biggest effects, come from hospitalizations due to pregnancy, or what I'm calling maternal or pregnancy-related care. However, if you compare them to the average hospitalizations by diagnosis, is still one of the biggest. Is one of the biggest. So this is the green line that you observed in this graph. The infectious disease line is the black dots line that in absolute terms seems not to be very high, but when you compare it to the average hospitalizations for infectious diseases is quite high. So this is why I'm saying that infectious diseases and maternal care mainly explain the increases in hospitalization rates. But I want to dig further into the subcategories within infectious diseases and maternal care, because in general terms, infectious diseases and maternal care tend to affect primarily children and women, which tend to be sometimes more vulnerable populations. So when I do this same exercise within subcategories of the infectious diseases, I find that morbidity outcomes within the subcategory that includes things like viral fevers like dengue, Zika, yellow fever, or arthropod or vector-borne diseases such as malaria are the ones that are increasing in temperature. So again, highlighting those that are significant. When I do this for the subcategories within the maternal or pregnancy related care, I see that hospitalizations due to fetus stress or fetus health are explaining why women are going to the hospital, and also women are seeking their own care for their own problems. So maternal disorders like infectious diabetes and malnutrition are sending women to the hospital after hot temperature shocks. And this is what I'm highlighting in this graph. So what I've showed you so far is the relationship between short-term variations in temperature and morbidity. So in trying to link these estimates to climate change and to the potential long-term effects, I'm going to be using the historical change in Colombia's temperature distribution. So the graph that I have here is the average temperature distribution for 2 time periods. So the dark gray bars correspond to the average annual distribution for the period 1985 to 2008, and the light gray bars are the annual temperature distribution for the period 2009 to 2016. The pink bars represent the change in that distribution. So you see that in general terms, Colombia has been becoming warmer. So the temperature distribution, in fact, has shifted to the right. But you see that most of the action and most of the things that are happening are in the moderate or mild temperatures, which are from 19 or from 17 to 21 degrees Celsius. So assuming that temperature distribution is going to be shifting in the same way in upcoming years, and I'm assuming no further adaptation measures are undertaken, I estimate that a shift in the temperature distribution similar to what we have observed historically results in approximately 1,100 additional hospitalizations per year, which is approximately 33.6% of the annual rate. So these results suggest important increases in the demand for services if temperatures continue to rise as they have been doing so, but it also sheds light on how health systems could help mitigate the adverse effects of climate change. It could serve as an adaptation strategy to reduce the negative impacts of rising temperatures. So to conclude, this paper advances our understanding of the temperature health relationship in a tropical developing country. I show that even small variations in mild temperatures affect morbidity, particularly infectious and maternal or pregnancy health are important in explaining heat-related health complications. And health systems might play a significant role in reducing the impacts of climate change. I am at this point exploring how I can formally test this hypothesis, but as of now, this paper is shedding some light on the importance of access to good quality services to reduce the negative effects of climate change. So thank you very much.
Okay, thank you, Juliana. Again, you did very well with time. So if you want to jump in with questions, anyone? Camilo?
Thank you very much, and thank you to Juliana for this excellent research. Is quite interesting. But maybe thinking on the data set that you're using for external hospitalization, and the actual situation of the attending to formal health, I could maybe tend to think that what you're finding is lower bound in terms of the whole impact. CISPRO as well as RIPS contains information that comes from the formal health system, and this could imply that we are not observing individuals that become sick due to the extreme heat, and you are not taking those in consideration. Is my main perception, but yeah, I think it could be a lower bound for a larger impact for extreme weather. Thank you.
Thank you, Camilo. Yes, I hadn't thought about that. I will definitely take a look on how underestimated the visits are in that data set. My sense was that since most of the Colombian population is covered by either regime, if people here are familiar, Colombia has two regimes: one public, one subsidized, and one that where you pay for. I think coverage is around 90-something%. So my sense was that it is quite complete in the sense that most of the population is covered. But yeah, as you said, we might be, I will look into that, and definitely, yeah, we could have a lower bound estimate, which is in that sense good for me, because I'm not overestimating anything.
Exactly. Now, this is important because we are thinking on we are moving ahead to an increase in temperatures, you know, and we are having situations right now what could be larger than the expected ones, and then with a hotter future is going to be inclusively more harder to deal with.
Yeah, and I think what is interesting here is that it's not necessarily at super extreme hot temperatures where I'm finding the effects, which was sometimes my concern with, yes, it's true that we had been observing 40 degrees Celsius days and something like that. But in places like Bogota, where we live, that is not the case. However, what my estimates are showing is that even at the mild temperatures, changes and increases might have an important effect.
Okay, thank you.
Thank
Anyone
you.
else? Natalie?
Hi, Juliana. Long time no see. I
Hi,
just wanted
Natalie.
to add to that another argument for calling these maybe lower bound effects is this recent paper by a colleague here, Paulo Pereira, in Sao Paulo, showing that our countries are countries with health capacity constraints, right? So if you have this, let's say, spike in temperature, right, you may crowd in hospitals, which are already crowded, right? So that may, displace health services provided to other diseases, and so that may be interesting to look at, right? Because you have more people getting admitted to hospitals, and that may affect the admission of other patients. Just that.
Yeah, that is interesting. And after the pandemic, I think we all understand what crowding of hospitals look like, I think.
Thank you, Natalie. Anyone else? Okay, so no, you're not off the hook. I have questions. So, well, not off the hook, but so there's a couple of questions and a suggestion. You don't need to give extensive answers now. But the first one is related to something that you've mentioned, which is adaptation. And when we look at those papers of mortality in high-income countries, for example, well, there's this attenuation of mortality due to air conditions, for example. So I wonder So I wonder whether this may have an implication for your comparison or your analogies with the developed world, where adaptation might be more prevalent, and I wonder whether there's some of this going on in some of the regions that you're looking at. Whether there's any other. Of course, this is not extremely hot or extremely cold weather, so maybe adaptation is just a fun, right? But I'm wondering.
So yeah, I have a paper actually relating mortality, temperature, and adaptation. And indeed, I'm not considering the air conditioning strategy to adapt, but in that paper, I'm considering access to healthcare as a mechanism to adapt. And what I find is that indeed, access to healthcare explains a lot of the reduction in the effects of cold temperature shocks in Colombia. On the hot part of the distribution, access to healthcare does not seem to do much. What does is like the quality of healthcare. So I have in the other paper I have a measure of quality, and I'm interacting it with that. My thoughts on if access to air conditioning would do very good in a place like Colombia is that it's not going to be that much, because what I find in that paper also is that the mechanism behind the temperature mortality relationship is again mainly attributed to infectious diseases. And so what I've been thinking about is what type of policy might help reduce the incidence of infectious diseases. And I don't know if air conditioning is the more appropriate one, because air conditioning is very appropriate when people are dying of heart attacks, because that is a technology, or cardiovascular illness, because that is a technology that helps thermoregulate your body temperature. When it's mainly driven by infectious and respiratory diseases, which is what I find in my paper, my big concern is that AC is not necessarily addressing the issues with infectious diseases. And so I've been thinking about policies that could help reduce mortality through reducing the incidence of infectious diseases and respiratory diseases.
Well, water and sanitation sounds like the first one, no? Access to good water and sanitation.
Exactly, something like that. Or I know in Mexico,
the relationship between temperature and disease and morbidity.
Yeah, I know, for example, that in Mexico they had some spraying of bugs or spraying when there was a dengue outbreak. There were some brigades of people spraying with, I don't know, poison or something to kill the mosquitoes and things like that. So yeah, as you say, also sanitation might be a good way to explore this.
So my only two comments, and you don't need to respond, is that so I was wondering whether you should interact humidity and temperatures, because a hotter temperature is much worse when it's much more humid.
Mm-hmm.
That can have effects. And the other is that what's interesting, I think you mentioned this, is it's not the levels, but it's the slope. So for example, for pregnancy, I think what matters is that the marginal effect of being in the next bin, that is very large, rather than the levels. So so I think that matters a lot for the interpretation and for the type of images that you may want to convey in terms of your evidence.
Okay.
Yeah.
Yeah. Agree.
Yeah. So
yes, thank you.
That's all for me. Anyone else has a question, or maybe we should get to the last paper? No. Okay. Bridget, would you mind timing me?
Sure, I can do it.
Okay, so thanks. I know you will be objective. Let me see if I can share my. No, it's not working. You see, it worked before, it's not working now. Okay, so what I was planning to do is not working. So let me, oh no, sorry, I'm having technical troubles. It's good that we have a bit of extra time. Anyway, let's go with this one. Yeah, okay. Okay, okay, sorry about this. I tried something and it didn't work, as usual. So can you hear me?
We can see and hear, but it's not full screen in like presentation mode yet.
It's not. Hold on. Is it now?
But that may be close enough
Okay.
if you want to give up.
I'm not sure what's happening. I'm seeing a full screen here, so that's why I don't understand. I tried everything before the start of the session. So you can't see full screen?
We can see the presentation. It's just not like Control L. It's just not like in full.
Is it
screen
moving?
presentation.
Are the slides moving?
No.
Okay, so something's wrong with. Let me stop sharing. Sorry about this, but it was working before. What about now?
I mean, it's the same, but try moving the slides and see if it works.
It says sharing is paused, but I don't know why, because it's not moving.
No.
You can try hiding the sidebar, like the one with the references and those.
Hold on, let me check.
Or maybe share the slides with Bridget and she can share it and I can time you.
Hold on, let me check.
Now it's working.
Now it's working. Yeah.
Yeah, it looks good.
Okay, sorry about this. We tried before, but of course I said it wouldn't work when I started. Okay, sorry about this. This is a paper on labor supply on high pollution days in Mexico. I'm writing this paper with Bridget, who's presented the first paper, Bridget Hoffman at the Inter-American Development Bank. So, so someone at least will like the paper today. So we start from the very basic observation that we all know that air pollution is bad for health. And we know that it's bad for respiratory diseases, but there's now more and more evidence that it's also bad for other types of conditions, such as mental health or even physical conditions that are affected in terms of the development of children that are exposed to air pollution. So in many cities in low and middle income countries, they experience high level of pollution. This is the case of Mexico City that we're going to look at. And these levels of pollution exceed substantially the guidelines established by the World Health Organization. So the question is whether the workers can avoid these levels of pollution somehow. And as we've seen with the pandemic, sometimes staying at home or not working on a day where you are exposed to a disease or to, in this case, to pollution, may not be convenient for certain type of workers, particularly those who are who depend on their daily labor supply to either generate income or to maintain their employment. And the other thing that could happen is that even if you can stay at home, given the poor quality of construction, that may not be enough for you to be shielded from the bad effects of air pollution, particularly if the housing is of bad quality. So what we do in this paper is we try to investigate whether workers adjust their labor supply on high pollution days by looking at labor supply responses in Mexico City. And because what I was mentioning earlier, that some workers may not have the luxury of staying at home on a day where they want to shield themselves from pollution, we look at heterogeneous effect and try to understand whether the response vary for lower income or informal workers. And because we exploit highly granular data, we can also look at whether workers smooth the responses, whether workers try to reallocate the working hours across days or even across household members that may be exposed to different occupations and may take different decisions. And from end on, we try to understand the mechanisms and the implications of these effects, why workers respond in the way they do, and we look at work commitments and income constraints. We look at the role of information by looking at pollution alerts, and we also look at the implications in terms of hospital admissions associated with to respiratory diseases on these high pollution days. So we know a lot about the effects of pollution in terms of diseases. I mentioned these, respiratory and other diseases, subsequent hospitalizations and mortality. We know that there is a short-term relationship between pollution and labor outcomes, but what we know is quite aggregate. So all the papers that have looked at this, they usually use some temporal aggregations such as weekly levels of pollution or even longer periods of pollution. And that doesn't allow to understand well how the exposure works if there's a lot of variation across time in terms of pollution levels. We know that there is avoidance behavior. Bridget talked about this earlier, but there's other papers that show it. And we also know that the health effects of air pollution are stronger for lower socioeconomic status individuals. So we look at this question in Greater Mexico. We have data from 2005 to 2016. And we look at particulate matter, which is an important air pollutant in Mexico that have the standard sources. And we think the context is important, not only because of the high levels of pollution, but also because of the type of labor markets that we observe in Mexico City, where more than 50% of the workers are informals, 80% work in retail or services, and the average education is below secondary school. So we have a lot of data. We look at the National Survey of Occupation Employment, NOE. There is a rolling panel conducted quarterly, and households remain in the panel or in the survey for 5 quarters, for 5 consecutive quarters. That allows us to exploit some panel components. And then we have very detailed information on days work, hours worked per day during the reference week, formality status, sector of employment, and so on, and of course all the socio-demographic. We merge this with environmental data that is also very detailed. It has hourly measures of air pollution. It has daily temperatures, wind speeds, wind direction, etc. And then we match the localities that are present in the NOE survey with the different monitoring stations, which are more than 40 that operate in Mexico City. And then we have some data on daily hospital admissions that again will allow us to look directly at the day where high pollution happens and whether that coincides or not with the day of hospitalizations. So our approach, we will use hourly measures of pollution. We will focus on PM 2.5, but we could look at PM 10 as well. We have hourly data that can better capture the peaks in pollution rather than just averages. So as I was saying earlier, when you look at weekly averages that are often used in some of these other papers, of course, averages tend to average out peaks. And what we want to focus here is on days that have very high levels of pollution, way beyond what the WHO think it's reasonable. So in that way, we will explore these nonlinear effects of pollution. We use daily hours of work, and we explore heterogeneous effects by informality and income level. And we also look at intertemporal responses by exploring not just high pollution days, but what happens on subsequent days as well, and daily hospitalization data. This is the area we're looking at is not just Mexico City, but also some of the localities surrounding Mexico City, which belong to the Estado de Mexico. And the red dots are the monitoring stations, and the yellow lines are the distances to the nearest monitor station from different localities. So the WHO, the World Health Organization, has some air quality guidelines. Basically, any pollution above that air quality guideline is harmful for health and can have long-term implications. So that would be like the standard of clean air. But because this is unlikely to happen in many of these high pollution cities around the world, the World Health Organization also has some targets that goes from interim target 1 to 3, which are basically different levels of pollution levels. And if we look at the maximum level of pollution that a locality has on a given day in our sample, then you can see that most of the days are above the air quality guidelines, and a significant amount of days are also above the least ambitious interim target, the one that it has the highest pollution level. Yeah. So maybe to show you some numbers about that, 64% of day localities are above the air quality guidelines, and around 6% are above the least ambitious target in terms of pollution levels. Yeah, but even the target is around 50% of the days for the third target. So some key statistics from our sample. As I was saying earlier, more than 50% are informal. Only 57% work for a wage. That means a lot of people may receive their income in commissions, or according to how many hours they work or how many things they sell, and so on. Around 60% are male. Average years of education is 10.5, and the average hours worked is 6.3, and that includes weekends. Yeah. And as you can see, 76% of the days these workers are working. So that means that it's more than 5 days a week that these workers are in income generating activities. Okay, so we have an analytical framework to try to rationalize what could happen. The idea is that pollution can reduce health directly and can also reduce productivity. So on high pollution days, leisure becomes more attractive, right? Relatively more attractive. However, for individuals whose levels of consumptions are really, really low, income effects are really strong. So having lower productivity means that for an additional hour, you get less. So if you have very low levels of income and your marginal utility of consumption is really high, you may actually compensate by working more hours. Yeah. So that means that for poorer workers or workers with lower productivity, we expect that the response to high pollution levels will be more muted than for, let's say, formal workers or high income workers. So empirical strategy, we exploit the granularity of the data. We have an individual I in locality L in municipality M on a day T within a week W. And that's when we observe basically a single day in a week for a given worker. And then we measure at the locality level for that day, the level of pollution. And that could be the number of hours above each of the different thresholds that I was discussing. We have a lot of controls that vary across time, locality, individuals, and so on, including temperatures, rainfall, education levels, or age, or gender, and so on. We have a lot of fixed effects, and we tried many different specifications. So let me move to the results, which is, I think it's more interesting. So findings. First set of results, we find strong nonlinear effects of pollution on labor supply. The marginal effect of pollution is larger at higher levels of pollution. And by higher, we mean that the probability or the quantity of hours a worker works is much lower on days with pollution levels above the least ambitious threshold, above the interim target 1. So as you can see, air quality guidelines, days above that doesn't have any effect on labor supply. And that makes sense because as we just saw, more than 60% of the days, or around 2/3 of the days, have pollution levels above the air quality guidelines threshold. So that's why it's expected that we wouldn't find any effect. But as we move the threshold to higher levels, then we find a decreasing effect on daily hours worked. Second set of findings, the effect of high pollution on labor supply are sizable and heterogeneous. The net negative labor supply response is significantly larger for formal workers than for informal workers. So by sizable, I mean they lose around half an hour on a 6.5 hours a day work. That's around 7.5% hours work on average that are lost on high pollution days. And this is robust to different specifications, including individual fixed effects. Because as I was telling you, we follow households and individuals over 5 quarters. Over 5 weeks in 5 different quarters. So basically sizable effects of pollution on labor supply. These results are robust to many specification checks, to using PM10, to using an IV specification with wind speed and direction in line with other papers. A nice placebo result that we have is that there are no effects on usual hours that workers declare that they work. So that the sample drops considerably because not all of the workers report that, but for those that report, we don't find any effect on usual hours work. And even though the effects are coming mostly from the extensive margin, the decision to work or not on the day, with some specifications, we do find adjustments on the intensive margin as well. Heterogeneous effect, informal workers, but also those that are self-employed or low education or low income, they respond significantly less. That means that on a high pollution day, an informal worker is less likely to stay at home or to not work. Result 3, or third set of findings. There's evidence of intertemporal labor supply adjustments. Workers compensate by working more on subsequent days. And interestingly, informal or low-income workers adjust less as well on subsequent days. And overall, they end up working fewer hours per week. So this is a nice summary of those results. So the red dots are informal workers, and you can see they work more on the day of that is above the interim target 1. But on subsequent days that can be seen in lags 1 to 5, they work less. So they compensate less than formal workers, which are the black crosses. So what we see here is that on high pollution days, informal workers work more, and on subsequent days, they compensate less. What we find overall is that when we add up all the hours worked for a week, informal workers seem to be working slightly fewer hours overall. So this is consistent with some other evidence that informal workers have lower elasticity of labor supply. There was that paper by Seema of rural workers in India, and Seema Jayachandran, and these results are consistent with that. But this represents also like a double whammy on those workers, because they work more on days that are more polluted and are more harmful for their health, but overall they end up working fewer hours because they compensate less. So they may be suffering both a health shock and an income shock that basically relative to formal workers. So informal workers are really suffering these pollution shocks. We have some additional results on labor supply. Effects are larger at the household level. That means that there is very little labor reallocation, or that the shocks within the households are correlated. Again, we find that low-income households respond less. The responses differ after consecutive days of high pollution. So after 2 or 3 days of high pollution, people go back to work. Yeah, so the gap between low and high income workers becomes smaller and smaller, simply because after 2 days of high pollution, everyone goes back to work. And we exclude days where there are some public alarms, which are very few days, because the alarms also happen at very high levels of pollution. And on those weeks, responses are stronger, but other than that, the results hold even when excluding the alarm days. So the fourth set of results is that hospitalizations for respiratory diseases increase, and the effect is larger in localities with higher share of informal workers. So again, a similar image that will summarize these results. We simply find, again, a nonlinear increasing effect on higher pollution days. And these are admissions for respiratory diseases to hospital. And what we find is that admissions to hospital for respiratory diseases are significantly larger in municipalities that have a higher share of informality, of informal workers. So again, this suggests that informal workers are more exposed to these pollution shocks. These results, again, are robust to a series of specification checks, whether we change individual controls, fixed effects, whether we include or not weekends. We don't find any effects or any evidence of nonlinearities when we look at other diseases, such as digestive, urinary, or circulatory diseases, or hospitalizations due to that. And we have some data on daily death, and we do find strong nonlinearities on same-day death due to respiratory diseases, and no evidence of other causes of death. Again, this is linking daily levels of pollution with daily health effects. So conclusion, workers reduce their labor supply on days with high pollution levels and compensate on subsequent days. Informal and low-income workers respond less. They are more exposed on high pollution days and cannot compensate as much on subsequent days. And then hospitality goes up, particularly in high informality municipalities. Okay, so that's it. I hope I'm on time.
Yeah, perfectly on time.
Yeah, so
20
probably
22
rushed. Yeah.
minutes.
That means that I rushed. Okay. Okay, I'm happy to take any questions. Yeah, Camilo?
Thank you, Juan Pablo. Thank you, Bridget. I think it's nice to continue seeing this research. This effects on the employment is basically the whole thing. No, there is no heterogeneous effect inside the occupation in terms of, because we have construction or we have informality, for example, is commonly is the person selling something in the streets and this kind of stuff. I saw that in the descriptive statistics, you have that there are percentage, I don't recall the number, but are retailers, but I don't know in the other potential factors. It could be interesting because it's in line with what the Climate Impact Lab from Berkeley is finding, that basically construction workers are working less hours per day due to extreme heat. This is another thing that is in nature, but in this case, I think that the heterogeneous effect could be interesting. And another maybe clarifying question is with respect to the data. So you have this labor force data that is quarterly, and then you observe each individual responding in a particular day, and then you trace out during that week what was the particular pollution levels.
Okay.
Thank you.
Yeah, thanks, Camilo. First, with occupation, we did look at that. We tried to look at that. We tried also to look at whether workers work outdoors or not. So we don't find anything interesting along those dimensions. And it might be because a lot of the informal workers that are not in construction are also exposed to, I don't know. Basically, they also rely a lot on their daily income, and they just reduce their labor supply on those days. So we don't find anything along those lines. In terms of the data, yeah, I know I rushed through a bit. So what we have is that we have so the survey asks a household on a given day about the reference week, which is the previous week. And for that, you have information on every day. Yeah. So we match that exact day with the pollution levels of that locality on that exact same day. Yeah, and we have that for all the days of the week. But this, because the survey follows, is quarterly, so every 3 months, they follow the same household for 5 quarters. So what we have is that, let's say for one worker, we will have 7 times 5, 35 days, basically, of information. And they may come back to the sample 5 years later. So we have the personal ID, and we could even have more data per worker.
But in terms of the location of the household or the worker, you have the information is the location of the survey, but not for the job post, or do you?
No, exactly, you're correct. So we have information on where they reside, not where they work.
So in some sense, it could be another that the parameter that you find is a lower bound because it could be nearest to the center of the city, for example. There commonly is the highest level of pollution. So maybe that could be interesting to explore.
Yeah, so I was checking that, and there's a lot of variation across localities, even neighboring localities, and within locality across time. So there's a lot of variation. So it is true that some areas may have a higher incidence of pollution than others, but I don't think we would be capturing a locality specific effect or something like that.
Thank you very much.
Thanks for your questions. Anyone else? No? Okay, so we have, I think, 4 more minutes before the end of the session. So if anyone wants to discuss with any of the authors about any of the papers, maybe we can just do that. So I was wondering, Juliana, don't you have more granular data in terms of time, like monthly or weekly?
No, unfortunately, no. For mortality, I do have it at the monthly level, but for morbidity, only at the year level.
Okay.
Yeah, I'm
So-
trying to find more data, but as of now, I haven't been able to find.
And yeah, that was. Okay, so if there's no more questions, thanks a lot to everyone, and I hope you enjoyed the rest of the conference. Yeah.
Thank